All right, algebra students, this is review from what we talked about at the end of class or in the middle of class on Tuesday. So right now we are working on graphing quadratic functions. Those are functions that look like y equals ax squared plus bx plus c. Right now you should know that the x-coordinate of the vertex can be found by taking negative b over 2a. Now what's important is the graph of a quadratic function is a parabola. And you can plug in any value you want for x, but if you plug in this value, you'll find this point right here known as the vertex. So you can find the x-coordinate of the vertex using this formula, which comes from the quadratic formula, right? It's just the stuff without the plus minus. Once you find the x-coordinate of the vertex, you plug it in, you find the y-coordinate. Then you know the xy coordinate here. You can then draw a vertical line called the axis of symmetry. Remember earlier in the year, vertical lines are of the form x equals. So x equals negative b over 2a, whatever that number is also the axis of symmetry. C is the y-intercept. We know the y-intercept because if you plug in 0 for x, you get 0 squared times a plus 0 times b, and then you're just left with c. Alright, sorry about that. Let's get everything back. We have the choir of the upper school for girls outside my apartment about to sing something in the Great Hall, so I apologize for that. Charlie started barking and I had to deal with that, so I'm just recreating everything we had. And then you've got the graph over here, shape here, vertex is this point where the axis of symmetry hits, and we talked about the y-intercept would be the point 0, c. Now what we talked about in class was this idea of the a value, and the a value will tell you two different things. One, you need to know if it's positive or negative. And based on it being positive or negative, you know the parabola opens up or it opens down. For this one, I've drawn a default that the a value is positive. And then if the absolute value of a is bigger than 1, or the absolute value of a is between 1 and 0, that tells you what kind of stretch the graph has. Now, if the absolute value of a equals 1, then it has no stretch. When we talk about things being stretched, that we're comparing those to something else. So a vertical stretch means it's stretched compared to some base comparison. And then a vertical shrink means it is not as big or vertically stretched or whatever than a equals 1. So we need to know what happens if it's 1. We're going to write no stretch. So let's put this all together with an example, something like y equals 3x squared minus 6x plus 2. And we start by finding the x. Well, let's just start with the a value. It's so easy. A is 3. That means it opens up and it's vertically stretched. The next thing we know is the x-coordinate of the vertex is at negative b over 2a. For this problem, that would be x equals 6 over 2 times 3, which is 6 over 6, or 1. That's also the line of the axis of symmetry. X equals 1 is a vertical line that goes through the middle of this parabola. I plug in 1 for x and I get y equals 3 times 1 squared minus 6 times 1 plus 2. When I do that, I end up getting 3 minus 6 plus 2. That's negative 3 plus 2, which is negative 1. So I now know the vertex, the coordinates of the vertex are 1, negative 1. And I know the y-intercept. The y-intercept is the value of c, which is 0, 2. Now when you go to graph, you want to be thinking about where your vertex is. I know the vertex is at 1, negative 1, so I'm kind of making sure that my graph can have that point here. And then I have the y-intercept, which is 0, 2, and because I have this vertical line of symmetry, this is 1 away from the vertical line of symmetry, so I can go 1 away on this side and mirror that point. And I have this parabola that appears to be vertically stretched and it opens up. If it's with all my information, notice I have x and y. Good? Let's try another example. Another example could look something like a little tougher. y equals 1/4 x squared minus 2x plus 1. So again, let's make it negative. So I'm going to change this negative 1/4. So a is equal to negative 1/4, which tells me my parabola opens down and it is vertically shrunk. Once I know it's vertically shrunk, because this is a number between 0 and 1 when I ignore the positive negative sign, down because I know it's negative. Now, x equals the opposite of b over 2 times a. This is a little tougher, but you can do it. That's 2 divided by negative 1/2. So 2 times negative 1/4 is negative 1/2. 2 divided by negative 1/2 is a negative number, and it's the same as 2 times the reciprocal of 1/2. So that ends up telling me that the x-coordinate of the vertex is negative 4. That also tells me that the axis of symmetry is the line x equals negative 4. I now plug in negative 4 into the function. Now I'm going to use a little bit of a different color to do this. Y equals negative 1/4, then parenthesis, negative 4, close parenthesis squared, minus 2 times parenthesis, negative 4, close parenthesis, and then plus 1. So now we have negative 1/4 times 16 plus 8 plus 1. That gives me negative 4 plus 8 plus 1. That ends up being positive 5. So the vertex is the point, negative 4 comma 5. Notice I'm labeling the vertex. I'm showing all my work for finding that. And the last thing I'm going to write down, I've run out of room, but I'll just put it over here, that the y-intercept is 0, 1. Now I'm thinking, okay, I need to draw my graph, so how about I draw my axes like this? Notice I didn't have much room, but I was able to fit some interesting things here by going over 1, 2, 3, 4, and up 1, 2, 3, 4, 5. Here's that point, the vertex. Here's the y-intercept. I'll use a different color for the y-intercept, and then I'm going to mirror that y-intercept across the axis of symmetry. This is a distance of 4, so I go 4 away from the axis of symmetry to the same y-coordinate, and now I connect these points using a curved shape called a parabola. At the very end, I check to make sure that everything I said before is true. Does it open down? Does it look vertically shrunk? Is the vertex where I think it should be and the y-intercept where I should think it be? Yes. All right. Come into class tomorrow. I want you to try these two examples. Y equals negative 1/3. We'll go positive 1/3 x squared minus 12x plus 5. How about, no, not plus 5, minus 5. And then the other one that I want you to try on your own is y equals 4x squared minus 16x plus 1. Okay, check your answer on this website, desmos.com, or you can use your graphing calculator. But this is the website I used the other day in class to show you some graphs. So try this on your own, get the information. Another interesting website to use might be Wolfram Alpha, which could also give you more information about these. So wolframalpha.com. Both cool math websites. All right, thanks for watching the video. Have a great night. Peace.